In continuation to this sample and hold device that we have already discussed so far, we are trying to find out how this sample and hold is happening. The functional representation or the graphical representation of a sample and hold circuit that we have seen here. Now, if any analog signal of this form is given as input to the sampler here, now we are going to get an output. Now you have two different modes of operations here. One is the sample mode, one is in the sampler operations you are having one as the track mode and the other as the hold mode. Now we are going to see what is a track mode and what is a hold mode. As we can see in the immediately after this functional representation, graphical representation, we can see that the track mode and the hold mode are not instantaneous. There is some time delay between this time, the track mode and the hold mode, which is called the aperture time. Now these are the very important terminology that we will have to remember when we are trying to discuss this track mode and hold mode in a sampler. Now let us say we have a signal, continuous time signal going like this. Now for example, if I have given a sample and hold command here, now let us say the device is in the track mode. For example, if the track mode is here and track mode is running, and at this point of time I am giving the hold command. At this point. That is, during the hold command, the switch here is opened. During the track mode, the switch is in contact with the other part of the circuit. That is, the input buffer amplifier and the output buffer amplifier are connected together when the switch is closed. Now, during hold command, the switch is opened. When the switch is opened, what might have occurred here? The system, the capacitor must track this value, but instantaneously it is not able to track this value. It is the system or the device is still in the track mode, and after a certain time, only from this point you can say the hold mode is coming into picture. Because of the various technicalities or non-linearities, you can say, for example, if I draw a horizontal line to these two, what is happening inside the circuit, the capacitor. Now at this point, the difference between these two, this is called the aperture time. The difference between that is the instant at which the hold command is given and the instant at which the capacitor is able to hold the value that is tracked by the device. Then the difference between these two is called the aperture time. Now eventually now you can call this as the track mode. This is the track mode, and eventually we can say this is the hold mode until the next instant you are having the hold mode. Now, and since the capacitor, though we have taken a very high quality capacitor with low dielectric absorption characteristics, it is not in a position to hold it. It will try to hold it, but it is holding it like this. The capacitor is discharging in this way. Now the difference between these two is this and this. This is hold mode droop. So it means that what we can try and understand here is that the time duration, the sampling period T must be as small as possible. Otherwise, see, if you are having this, if you want to track this signal, your time period must be as small as possible. This is the time period that you will have to give. Otherwise, you will get a drooping characteristics you will lose certain information from the original value that you will have to obtain. So this is the characteristics of input and output, right? So these are the input output characteristics versus time for a sample and hold device. Okay.